real benefit of these conferences. So the next segment today is going to be on, we talked earlier about everybody's in the race to be second, right? Especially the public owners there, they're careful. The race to be second, you guys are won the race to be first, and you found somebody for that marriage, and that's always good. It's great to see the owners that will think outside the box and move forward. So the next one is on BioHiTech technology, lessons learned in being the first in the country. We're going to hear from Emily Dyson, who is the Vice President of Science, Research, and Development for BioHiTech Global, EWV, and we'll hear from Stephen Brooks, the Director of Engineering from Lone Cypress Engineering Services. Looking forward to hearing this one.
Is that good? Okay. Thank you for having us here today. As he mentioned, we are the first in the United States to be using the high-efficiency biological treatment technology that is patented by Ensorga Italia and BioHiTech. We own the technology rights for the 11 Northeast states, and we have permission to market in the rest of the states in the United States. So Refuel, you know, in business today, you've got to make a small company, a million small companies to get one big company to do things. So Refuel America actually is the one that owns the technology and the proprietary rights. Under Refuel America is Ensorga, West Virginia, which is that first plant in the United States using the HEBIOTT technology. We are actively engaged in developing technologies that divert waste from landfills. And in creating the space within the landfills, we're also making a viable, high-quality fuel that can be used in the cement industry, can be used in the power plant industry as the raw fuel that it is. The reason that Stephen is here with me today, Lone Cypress and BioHiTech have teamed together. They are Lone Cypress is the oil, gas, renewable energies company that we have teamed with to take our fuel to that next step, and we're ready to do that. We recently had some testing done, analytical testing done of our fuel. Back in 2013, we received an EPA, what at the time the EPA was calling a comfort letter, and the comfort letter basically said that we met the legitimacy criteria of having a high-value, quality fuel. And we redid that study again. That study was done using Italian fuel. We redid that study recently using US fuel, and it actually came back as a better fuel than what the Italian fuel had been. So we're really encouraged, and Stephen's going to share more what that means towards the gasification world for our fuel. As I mentioned, Ensorga, West Virginia is the first facility in the United States of its kind. Ensorga Italia has 11 of these facilities throughout Europe. So we are at a commercial scale. We're not bench scale. We're not just trying it out. We have the first facility. A little bit of history about the project. It took 13 years to get this project from first thoughts of the Italians bringing it to the United States to where we are today, generating fuel. I've been with the project all 13 of those years, from doing the permitting to getting financing to overseeing construction to actually doing some management of the facility itself. We've now hired a manager for the facility, a general manager for the facility. We are fully staffed, and we are at about, I'd say we're probably at about 40% production right now, and we're growing. As we jump the hurdles of being the first and figuring out what the differences were between the European waste and the US waste, and there were some significant differences, we've been able to make modifications to our plant and to help move it forward. Basically, the HEBIOTT technology takes traditional mechanical biological treatment and we kind of mush everything together. If you consider there's a three-step process, basically. There's pre-treatment, which is separating it by size. 7 inches and greater becomes an over. 7 inches and smaller becomes an under. The 7 inches and over gets made into fuel right away. The 7 inches and smaller, which is majority your organic material, as well as your tins, your aluminum. Some of your metals are going to come out there. A lot of your fiber is going to come out there. That all goes into what we call our biooxidation hall, and I'm going to show you all this here in a minute in a quick video. But that biooxidation hall basically is a huge composting facility that's indoors. There are no odors from our facility. Everything is put through a biofilter, which is a large above-ground swimming pool at the back of our facility. It's about 280 feet long, 8 feet tall, 50 feet wide thereabout, full of hardwood mulch ranging in size from bigger than firewood down to finely shredded wood. All of the air within the facility is negative. It's negative pressure in the building. It's pulling that air out, which includes all those odors, and pushing it through this biofilter. And the biofilter has done an amazing job of controlling those odors. So at the perimeter of our facility, and we are surrounded by housing developments, there is no odor. And it has been very impressive, and we've actually had a lot of regulators from surrounding states and from West Virginia in particular that have come to see the facility, but especially to take a look at the biofilter. So we began taking MSW. We take in municipal solid waste, just standard residential little house on the corner waste, as well as commercial and industrial materials, non-hazardous secondary materials, predominantly fiber as well as plastics, that we convert into a light, crunchy, fluffy paper by the time we're done. That's then used, currently, is blown into the preheater precalciner at a cement plant that's located about 2 miles from us. We manufactured our first fuel in May of 2019, and we had our first fire in September of 2019. As a lot of you probably know, waste facilities like to catch on fire. So we had a lot of lessons learned from that. We've installed thermal imaging cameras throughout the facility so that we have a constant sort of a recording of what our temperatures are. Luckily, we have not had another fire. We've actually had 2 fires, and we have not had one this year. Our facility right now takes in, we're permitted to take in 110,000 tons per year of MSW and CNI. Right now our model is, in West Virginia, our model is about 80% MSW and about 20% CNI. Models going forward, we're learning, are probably going to switch that up a little bit. We're probably going to go more like 60% MSW and 40% CNI, because the CNI market is so great, and because the MSW market in certain areas of the country, it's hard to get that much waste all brought to one location when you put in the transportation costs. So those are some of the things that we're looking at, and we're seeing that it's working fine to change that model depending on where we are. So we have some flexibility with it. This is a quick video. It's about 5 minutes long that gives you a day in the life of what our facility looks like, and I'm going to try and talk over it. We'll see how that goes. So the trucks come in. Everything is automated in this plant. Trucks come in. They dump into 26-foot deep pits. Everything is from the control room. So there's no guys sorting waste. There's nobody having to touch it other than if we have mechanical issues. We have 2 overhead cranes, 3 tons apiece. We pick about 2 tons per. Goes into the first hopper and then goes through a trommel, and this is where we're getting that sizing separation. This would be our unders, so that's our real good carbon material. That material is taken to this biooxidation hall. Currently, we have 4,500 tons of MSW in that biooxidation hall, and there are no odors. That was the mezzo shredder. That's the first shredder. This is the near-infrared sorter. That's kicking out PVC plastics because we can't have chlorine in our fuel. We have 2 magnets and 1 eddy current that's pulling out the metals, the ferrous and the non-ferrous, which then go into the recycling stream of the local community, and that's the actual fuel. We haul that fuel right now in 40-foot long walking floor trailers. This is the fan system, is the ventilation system that's pulling that air out of the building and pushing it through this huge swimming pool that you're going to see here in a second. There's 26 fans. We have 24 rows of waste within the building, and then this is the biofilter itself. You'll see in the left side, that's actually Argos cement, which is using our fuel. It's about 2 miles away. So I don't think any one of these talks is complete without figuring out where you fall in the waste hierarchy. So really where we fall in is the recycling and the composting, because we are pulling out the metals. That biofilter that you see that I showed you behind the facility, that material will actually be excellent for composting when it's done. And then energy recovery. Our fuel right now, the test results that we just got back, Stephen's going to give you a lot more details on it, but our test results really are coming in somewhere between 10 and 12,000 BTUs. So we are in the range with coal. Right now it's about 1.5 tons, 1.75 tons to a ton of coal is the offset that we use. Our emissions are lower than that of coal. In order to get our EPA comfort letter, we had to show that we were comparable to or better than coal on all of the hazardous constituents. So I did a real cursory review because we just got the results back, and we actually come out even better than we did with the Italian fuel. So that U.S. fuel is working very well in our system, and it's working very well for Argos Cement. We currently are contracted to provide them a little more than 3/4 of the fuel that we make, and they have made a request that we send them absolutely everything we can make as soon as we can make it. So that's a good thing. The biggest hurdles that we're facing right now is having the MSW, is getting enough MSW into our plant on a regular basis. So the process basically, like I said, it's 3 parts. It's pre-screening, so that's the sizing. It's the biological treatment in that big biooxidation hall. It's the mechanical refinement and sorting, which is pulling out the metals and the PVC plastic and then shredding it down to that 2- size. We lose about 30% of all inbound weight of our material is lost just through evaporation, through that whole composting process. We recover the PVC and the metals and the inerts. The inerts in particular, we're doing a study right now with Marshall University, which is a local West Virginia university, on where those fines can be used as an aggregate in road base, can also be used potentially in the cement industry itself. We'll be getting a lot of that data back over the course of the next month or so. And then residuals are landfilled. Those residuals are the things that you just can't make into fuel, like shoes and car seats and the other strange things that we get in the waste. So the benefits. Our facilities are modular to some extent, where we can ramp up by size just by changing the size of the biooxidation hall and adding another line within the refinement area. So we can go anywhere from 110,000 to 300,000 tons inbound of MSW and CNI. That material, we won't ever want to build one as small as 110,000 tons again. There's scales of economy and economics that just don't make sense to build them that small, but that's where we had to start in order to prove it out. We do increase the recycling rates in the community. We are located on property owned by Berkeley County Solid Waste Authority in West Virginia, and so we co-locate with them. We take all of their plastics, which they can no longer get recyclables. There's no market for it. They have no place to send it. So we're taking those, and they take our metals. So it works out very well. We also pay a community host fee. We pay 50 cents on the ton to the community that hosts us. In the state of West Virginia, they have a very strange way of managing their waste. They have a public service commission that basically guarantees that if you get a certificate of need within the state, then you won't have any competition. We were under the Public Service Commission. If you fell under the Public Service Commission, you also had to pay them $8.75 a ton of everything that you made. We are no longer, due to legislation that we got passed during the last legislative cycle, we're no longer under the Public Service Commission. By getting out from underneath there, we opened up the market of who we could accept, as well as not having to pay $8.75 a ton for all of our materials. The state of West Virginia saw that as a very positive move. They're very motivated to become something other than the coal state, which I find is interesting, and it's one of the reasons why we kind of chose West Virginia as the first location, is because they were such a coal-centric state, and they're looking to become the technology state now. Who is the technology right for? Well, counties, states, and municipalities that are having landfill capacity issues. You can basically think of a HEBIOTT facility as a renewable landfill. We just bring it in and send it out. As you said, we make shit disappear. I really want that on a t-shirt because it can be taken so many ways in the waste industry. We do achieve a more sustainable and modern waste management system. Waste management is on the forefront right now. We've spent 30 years educating people on recycling, and I don't know that it was overly successful. And we now need to spend the next couple of years educating people on the value of waste as a commodity and where it can be used to create energy within our country. We're behind on that, and I really think that needs to be a focus going forward for anybody in this industry. It is good work conditions. For our facility, we run 18 hours a day, and we run it with 15 to 18 people. Right now, labor is really hard to find and really hard to keep, so that's another one of the challenges that we're facing. It is a fully automated process, so everything is done from the control room. Private landfill owners also, who have limited capacity, who need to extend the life of their landfills, this is a good option. Co-locate one of our facilities on your landfill. You can even harvest landfills and feed our facility, is one of the other things that can be done with it. And then hauling companies. It gives you, it differentiates you. I know none of you guys are probably in the hauling world, but haulers now need to find a different story to tell as to what they're accomplishing. So what have we accomplished in our first full year, which would have been in 2020? We received 23,492 tons of MSW, so we were only at about a quarter of where we need to be. We received 3,607.45 tons of C&I waste, and that's growing every day. We sold 11,062 tons of SRF, so 615 trailers made its way over to Argos and back. And we have already achieved the 615 trailers to date already so far this year, so we are improving. And then 41% of our inbound volume was converted into a high-quality SRF, and that's right within the metrics of what we thought it would be. So what's next for us? Well, due to West Virginia passing their legislation that made it so that we were considered a manufacturer and no longer a solid waste facility, we're looking to build more facilities in West Virginia. They want us, and we like to be there. We do have a permit in process in Rensselaer, New York. We have other projects in the New York area that we're keenly pursuing, and we're being pursued as well, which is good. And then expanding the uses of the SRF, that's really the growing market. That's where we need to be, and that's where Lone Cypress comes into play for us, is now that we know through Department of Energy grant programs, research that's been done, the analysis that came back on our fuel, we know that we have an excellent fuel for conversion into syngas or other gasification projects. So I'm going to turn it over to Stephen Brooks from Lone Cypress, and then we'll take questions afterwards.
Thanks, Emily. Good afternoon, everyone. My name is Stephen Brooks. Get this height right. Vice President of Engineering and Operations for Lone Cypress. Lone Cypress is an energy infrastructure developer based out of Tulsa, Oklahoma. We specialize in 4 different business lines within the broader energy value chain. The first being waste to energy, which is why we're here today. Additionally, hydrogen generation and distribution facilities, and so blue hydrogen, green hydrogen through the traditional methane to hydrogen pathway, as well as biogas to hydrogen. Also carbon capture, storage, and utilization. It's becoming a bigger and bigger business line as the years go by and regulatory environment shifts to be a little bit more stringent on associated emissions from industrial processes, transportation, and sectors of that nature. Last is traditional oil and gas midstream infrastructure, so pipelines, cryogenic facilities, amine treating systems, which when you look at those 4 business lines, it kind of seems like we're scattered all over the place, but they're all accretive to one another in numerous ways, which I'll get into later in the presentation. Lone Cypress specializes in project management, EPC services. We also do system operations and commissioning. Our relationship with BioHiTech is that we are project managers for all of the new facilities that they hope to build in the coming years, as well as investigating tailgate technologies to take the fuel that they're creating at present and gasify it, pelletize it, or make it suitable for end users depending on the jurisdiction in which you're developing the facility. So as Emily touched on, we feel that the HEBIOTT, or the high efficiency biological treatment process, creates a fuel that is more reliable and robust in terms of constituents. We like to separate the process into 3 distinct process areas: the pretreatment facilities with the tip floor, as she was showing in that video. Beneficial for the system because it helps the operators visualize and eliminate any of the inbound feed that won't be compatible with the system. Within the biooxidation, there's essentially those 26 fans that run off VFDs that are based on the automation of the facility. The system is actively testing for moisture content and then drying according to the needs of whenever the fuel has entered the system, and based on, I guess, the process through the system, either kicking on fans or, I guess, increasing flows or decreasing flows depending on how mature the fuel is in the process. And then last, the refinement process, where they're blending now this MSW that has come in, being treated through the pretreatment system and has gone through biooxidation, which essentially acts as a combustion environment. Within refining, you're now blending in CNI streams to increase the caloric content, and then it just ensures consistency with the fuel production process. As Emily alluded to, we've just reached our first year of full operations, and so it's taken us, I would say, this long to kind of understand operationally how our systems differ from the 11 that are operating in Europe. As all of you are aware, our waste streams in the United States are a little bit different than those in Europe. We really like plastics, plastic bags, and things of that nature, which like to get wrapped up in the pre-refinement process. And so it has been sorting through those, let's call it growing pains, that we now kind of understand what is the optimal layout for our system for the inbound MRF, the composition area, and the refinement. I think that positions us well to start a due diligence process to understand at the end of the plant, when we created SRF, what tailgate technologies can we put in place to make our fuel more acceptable for a larger market. As Emily alluded to, we actually just received some very promising laboratory results on the SRF that BioHiTech is creating. We've run a approximate ultimate analysis along with the heavy metals and a BTU analysis. Very promising results in terms of BTU content. We're right at that comparable with coal range at 12,000 BTUs per pound. Very low moisture content, anywhere from 8 to 10%, which is accretive to the gasification process. We also have low mercury levels, low sulfur content. The sulfur content being especially important for our offtake market at present. As Emily alluded to, our only offtake partner at Martinsburg is a cement kiln. In the cement industry, the alkali to sulfur ratio is very important for those systems, and so keeping that sulfur low is important for our offtake partner. They won't accept our fuel, and so again, just another benefit of the fuels that Insorga is creating through its process. Trace amounts of heavy metals, all promising signs for this next conversion process and the due diligence that we're doing right now. So where we are today is we know that we're creating a good fuel in our SRF that is superior to the RDFs that we've seen, in the sense that our BTU fluctuation is not to the large degree that you see with other RDFs on the market today. Moisture content is very low, and then other contaminants, trace amounts, or to the degree that we feel confident that any inbound facilities for the gasification process, or for even the waste to hydrogen pathway, that will eliminate a lot of those expenses and making those systems more efficient and economic. Our current process is just co-firing the SRF with traditional fossil fuels. As I said, the cement kiln that is about 2 miles away from Insorga, they are taking the SRF we're creating and then feeding it into their system where it is being coal-fired, or where it is being fired with coal slag. We had analysis of this process done on a bench scale with an engineering firm out of Florida, which showed very promising results, and then obviously is happening at a commercial scale now at Argos. And so that has been a good partner in the interim time, given in cement manufacturing, really the only thing that you're worried about is getting to that BTU level. But as coal-fired power plants are being phased out and the cement industry is coming under more and more scrutiny in terms of the emissions associated, We feel that the offtake partners in jurisdictions like California, for instance, become very, very limited if the prospect is taking our light, fluffy SRF and trying to make it, let's call it, compatible with existing energy systems, which is why we feel that the gasification pathway presents a lot of potential for expanding offtake markets. And so when we talk about these tailgate technologies, we are exploring the myriad of technologies that are on the market today, which is why we're here at this conference, and I hope to connect with some of you who are subject matter experts in exploring these things. We have found that, and I don't have to tell you, you have issues related to scale, right? We're at 150,000 tons of inbound MSW into Martinsburg, which translates to about, let's say, 55,000 tons of outbound SRF, which can't remember which gentleman said you're looking at around the 300,000 ton sweet spot for the gasification process, which kind of holds with what we've been seeing. And so we're trying to find a modular gasifier, but also exploring other options. Again, waste to hydrogen, our specialty at Lone Cypress being that hydrogen pathway, more from the methane origination route. But talking into biogas, we feel that the latest analysis we've gotten back on the SRF is very promising for the waste to hydrogen pathway, just given the low amounts of heavy metals and the necessary refining and purity required to get hydrogen to be compatible with fuel cells for transportation markets, which we feel is an emerging market for hydrogen utilization over the next, let's call it, decade. And then combining that with carbon capture technologies, again, just lowers your associated emissions. We've also explored torrefaction to just mild pyrolysis of the SRF to try to understand if maybe we can't stabilize the product. One of the issues that BioHiTech has with the SRF as present is fuel stability. If you let that fluffy paper sit out for, let's call it 48 to 72 hours, moisture leaches back into the system and it just becomes waste again. And so part of the pathway, part of the reason for trying to convert it to another fuel is the stability for transportation economics as well. When you densify the product, running it through a pelletizer or briquetting it, you can fit more in a truck, which obviously helps your transportation economics. And then also looking at gasification. Again, like I said, getting to an RNG and then being able to put it in a pipeline would be very favorable, especially in some of the potential sites that we're looking at. You run into a myriad of takeaway facilities, which are always different based on the project. And so we are keeping all of our options open in terms of the pathways we are exploring, knowing that what jurisdiction you're in, what the takeaway constraints, how much inbound MSW can you aggregate, how much CNI can you aggregate, all affects what outlet facilities will be required at the facility. So what are the benefits of SRF? Again, I spoke on the moisture content being in a range that is well apt for a conversion process, a heating value that is not like RDF in terms of its fluctuation and is very consistent and is very on par with fossil fuels like coal. We're also kind of stepping into, over the next, let's call it the last 24 years, with the IPCC recent report, as well as the Biden administration coming into office. Regulatory tailwinds in terms of just favorable jurisdictions to where we could potentially facilitate this operation. California being one of those, in the low carbon fuel standard credits that are available here. In jurisdictions like West Virginia, when you're competing directly with coal in applications like power generation, we feel that the SRF as is probably the best bang for your buck you're going to get in the market. But in other jurisdictions like California, if you could facilitate that pathway, you're going to get subsidized to a very large degree. And if you can combine that with some sort of carbon capture technologies and get access to that 45Q, that is also going to add buoyancy to your project economics. Emily touched on a lot of the sustainability metrics coming from the HEBIOTT technology. Obviously, just the diversion of landfill is a big plus. And then you're now diverting carbon out of a landfill and then upcycling that for uses in other energy systems. And that's going to offset emissions associated with, for instance, if you're knocking coal out of the system used at the cement kiln and you're using SRF instead, that is coal that is not being burned, and greenhouse gas emissions that are not being emitted to the atmosphere. What are our challenges? And I've touched on these throughout this presentation, but the first and foremost being skepticism from our inbound markets. Not only do I have to convince somebody that this garbage that I've turned into energy makes sense for their energy system, it's going to be reliable in terms of its caloric content, and it's not going to gum up the system that they currently have in place, which is a much bigger lift than it would seem on the onset. Additionally, just educating the public as to what can be accepted in the system. Emily touched on this, just the recycling education, or the push to educate the general public, and I guess the shortcomings associated with that. I know that she has a lot of, had to overcome a lot in Martinsburg. And then just educating the end users as to the benefits of SRF, and as well as also local municipalities, explaining to them that this isn't an incineration process. I know that everyone gets running and scared when you mention incineration. And then just general NIMBYism. I would say that I was pleasantly surprised the first time that I visited Martinsburg to be standing outside the property and not smell any associated gases that are coming out of the facility. Additional challenges relate to energy economics. Again, regardless of where you are and regardless of how incentivized the local municipality is to go greener, you're still competing with conventional fossil fuels when you think about translating waste into any energy system. Yes, and then in West Virginia, again, like I said, it's not a super favorable environment for that, but in California, we feel more confident that there's markets for fuels of this nature. Additional challenges, again, transportation economics. We've looked at applications where there's rail takeaway available, which caters very well to SRF. Also barge takeaway. Some jurisdictions there's neither, but you have pipelines in the area. And so it's just really figuring out the best to fit solution for the infrastructure constraints surrounding a specific project. And again, aggregating waste, obviously the inbound aggregation to justify putting down the initial MRF as well as the gasification process. And then making sure that if you are supplying SRF to some end user, that their energy system is compatible with the SRF. For instance, at the cement kiln that we are currently offloading to, we had to build a custom inlet system for the fuel, which just, again, adds another constraint to your project economics. Yeah, and so now I'll take any questions.
Would you know how much, what is the fraction of the biogenic carbon in your product versus non-biogenic?
One second.
I don't know it off the top of my head, but we did pull the carbon numbers.
Fixed carbon is 9%.
It's about 9% is the average.
9% biogenic out of the total carbon?
Yeah, that's the fixed carbon.
No. So the total carbon in the product is source is obviously plastics and paper and
Right.
everything. So how much or how much of the feedstock is biogenic versus non-biogenic
About 50%. It comes out to about 50-50.
in the product? 50-50.
Yes.
50-50. Do you know what is the carbon offset related to the product if it has gone through some energy conversion?
Did we get the 2,000 carbon equivalent? 2,000 pounds. I can get you the numbers. We've got them in a calculator spreadsheet that we've put together, but.
Okay. If can you comment on the economics, like, or if you can help us understand a little bit better about your cost, production cost, OPEX, and what is the value of the actual product to cement kiln?
Sure. So the plant was about, it came to almost $30 million with the full financing with the interest that we pay. And then we have an inbound market of about $53 a ton for our MSW. And we turn around and we sell our fuel for in the $30 range, 30s. And I know that that market is variable depending on where you go, which is why we own the technology rights in the 11 Northeast states, because that's where, you know, West Virginia and that $53 a ton is probably the least expensive that we can go and still manage to turn a profit at the facility. No, I don't care to comment on that.